In this video, I'm going to show you how to evaluate the limit as x approaches 0 of x to the x power. So the first thing that we need to do is call this limit some variable. So I'm just going to call that I. So we can say I is equal to the limit as x approaches 0 of x to the x power. Now what we can do is apply the natural log to both sides to try and get this exponent out of the power, because we don't want a variable in the exponent. That's not good. We can't really do anything with that. So we're going to say that the natural log of I is equal to, now I'm going to bring the natural log inside of the limit, and I can do this because the limit of this function is continuous from 0 to infinity, and the domain of natural log is also from 0 to infinity. So I can bring the natural log inside of the limit in this case. So I'm going to write that the natural log of I is equal to the limit as x approaches 0 of the natural log of x to the x power. And then obviously, using log laws, we can bring this exponent to the front of the natural log. So we can say this is equal to the limit as x approaches 0 of x multiplied by the natural log of x. Now, if we draw a quick graph for natural log of x, we can see that as x approaches 0, the graph of the natural log is actually going to be asymptotic to the y-axis, meaning it's just going to go down to negative infinity. So if we plug in our limits here of 0 multiplied by natural log of 0, that's going to give us 0 multiplied by negative infinity. But this is an indeterminate form and we can't really do anything with this, so therefore we have to do more work. So what we can do now, we know that if we divide by the reciprocal of something, then that's just going to be the same as multiplying it. So we can write that the natural log, x multiplied by the natural log of x is going to be equal or equivalent to the natural log of x divided by 1 over x. So if we put this into our limit instead of this, then see what we can do. So the limit as x approaches 0 of the natural log of x divided by 1 over x. If we put our x's in here, we'll know that this is going to go to negative infinity like last time, and I'm just going to write a negative at the front. So negative infinity divided by 1 divided by x as x approaches 0. Obviously, we know the smaller the denominator gets, the bigger the output will be. So this, as x approaches 0, is going to approach infinity. So we get an infinity over infinity situation. And this here is also an indeterminate form, but this is an indeterminate form in which we can use L'Hopital's rule. So that's what we're going to do. We're going to differentiate the numerator and the denominator. So d over dx of ln x and d over dx of 1 over x. And this is then going to be the limit as x approaches 0 of 1 over x divided by negative 1 over x squared. And doing some simplification, we can say that this is the limit as x approaches 0. We can bring this minus to the front of the fraction, and we can bring this denominator up to the top. So it's going to be the same as negative 1 over x multiplied by x squared. And then obviously we can put this x squared on top, which is going to, and then this x on the bottom is going to take the exponent away, because if you're dividing two things that have the same base, then you can just take the exponents away from each other. So that's going to be the limit as x approaches 0 of negative x. And of course, this is just equal to 0. But what we've worked out here is the natural log of I. So we can write that the natural log of I is equal to 0. And to get I by itself, we have to apply e to both sides. So e to the ln I is going to be equal to e to the 0. And obviously the natural log and the e will cancel out. So then we're left with I is equal to e to the 0, which of course is equal to 1. So therefore, we can conclude that the limit as x approaches 0 of x to the x power is equal to 1.